Hi sir, my name is Penithin. I'm here to discuss about some topics in satellite communications or satellite orbits, launch vehicles and power systems. In this, I'm going to explain the foundational concepts in satellite communication. First, the orbital mechanics. Understanding the precise physics governing the satellite motion is crucial for mission success and longevity. Launch vehicles. The method of deploying satellites into the orbit directly impacts cost effectiveness and mission feasibility. Ensuring continuous power and paramount for interrupted communication services is for reliable power systems. In this, we are going to discuss about orbital mechanics. In that orbital mechanics, we are going to discuss about Kepler's laws. The Kepler's first law. The Kepler first law is also called as the law of orbits. In this, the main thing is all planets move in elliptical orbits with the sun at one of two foci. For satellites, this means the path around the celestial body like Earth is an ellipse, not a perfect circle. Earth occupies one focal point. For satellites, this means their path around a celestial body is an ellipse, not a perfect circle. Earth occupies one focal point of the ellipse. In this, the distance between the satellite and the Earth varies throughout the orbit, which has significant implications for communications like budgets and the orbital perturbations. And coming to the next, the Kepler's second law. This is also called as the law of areas. In this, a line of segment joining at a planet and the sun sweeps out equal areas during the intervals of time. The law implies that a satellite moves faster when it's closer to the Earth at perigee and slower or farther away, which is also called as epoche. The area covered by the imaginary line connecting the satellite to the Earth remains constant over identical time periods. The crucial prediction of the satellite instantaneous velocity and its orbital position at a given impact of the line with tracking schedules. And coming to the third law of the Kepler's law, which is also called as the law of periods. Like it's also called the square of the orbital is directly proportional to the cube of the semi-major axis of the orbit. It is also called as the law of periods, which is coming to the t square equal to k into a cube, which is also called as t square is directly proportional to a cube. K is referred as constant. In these laws, allows engineers to calculate the precise orbital period of a satellite based on its orbital altitude and vice versa, foundational for designing specific missile profiles. In this, essential for achieving geosynchronous geostationary Earth orbits, enabling predictable communications and constant coverage for specific regions. These are the laws which have Kepler's are defined in three laws. And coming to the another topic called launch vehicles gateway to the space. In these launch vehicles, a launch vehicle is a rocket powered system designed to carry a payload from the Earth's surface into the space. In this, there are some key requirements which we can discuss. Must generate sufficient thrust to overcome the Earth gravity and achieve escape velocity, ensuring the satellite reaches its designated orbit. In this, the classification is broadly categorized into expendable launch vehicles and reusable launch vehicles, each with distinct operational philosophies. And in this, we are coming to discuss about ELVs and RLVs. In ELVs, the cost per ELV is high per launch, like single-use hardware, which can only we can use at a single time, and we cannot reuse at any other time instance. But coming to the RLVs, it is reusable launch vehicle. Which has lower cost for launch and optimized hardware, which is called we can use the parts for the remaining building the satellite. Reusability, the reusability is none in this ELVs, but comparing to the reusable launch vehicles, the that is partially used or full, like boosters, fairings, these all are used again, we can use in the another satellite too. And the payload efficiency, The payload efficiency is generally higher in ELVs, and coming to the RLVs, it is slightly lower than the ELVs. And the mass is dedicated to recovery systems. And the mission frequency, which is the main point of ELV and RLV, is limited by manufacturing times. The mission frequency is limited by the manufacturing times, whereas it is potentially higher in reusable launch vehicles. And coming to examples like in ELVs like PSLV, GSLV, Align 5. But coming to RLVs, it is Falcon 9, Falcon Heavy. And in this, we can discuss satellite power system, the lifeblood of communication, which is powered by satellite communications. The main part of the satellite is about satellite power systems. Power requirements. Communication payload demand substantial and stable electrical power for continuous operations, including transmitters, receivers, and onboarding processing units. And coming to the primary power sources, which are called solar arrays, are the primary power sources converting sunlight into the electricity. These will all know that about it. And these are supplemented by rechargeable batteries for the periods of darkness ellipse. Whenever the sun comes, another earth comes between the sun and the satellite, so they form an ellipse. So that form an ellipse will be covered by the batteries, which can be really clearly observe in the clear coming concepts. The solar cells and the batteries, sustainable orbital operations, which we are using here. The solar cells are these are photovoltaic devices converts solar radiation directly into the electrical energy. During sunlight periods, they provide power to the satellite and recharge the batteries. So this power will be used when the eclipse is formed. Whenever the eclipse is formed, there is no sunlight to the satellite. So the satellite should convert the energy to the transfer the energy to the transmitters and transponders which are fixed in it. So this energy is given by the battery which stores some energy, and it is reusable and rechargeable too. And coming to the batteries, they are rechargeable batteries which we use lithium, nickel, cadmium, and these are all the batteries which can store more amount of energy. So in this, store excess energy due to sunlight periods and discharge the power satellite during eclipses. So eclipse is the main drawback when the satellites can't get any energy. So these are the batteries which can overcome the situation. And coming to the conclusion, whereas power conditioning and final thoughts. This power conditioning is the PCU is the vital for the regulating filtering and distribution of power from the solar arrays and batteries to the satellite subsystems. It ensures a stable and clean power supply, protecting sensitive electronics. And this production and efficiency functions include voltage regulation and or current production and maximum power point tracking. For solar arrays, optimizing power transfer and system reliability. These are about the solar panels and the powers which we are discussing in the power system. And coming to the telecommunication, tracking and commanding and monitoring, this is also called as TTMC in short form. The TTMC is the lifeline for the satellite mission, providing essential functions for its operation and mission control. It is critical link that ensures a satellite health, safety and reliability from the moment of launch until its end of the life, facilitating continuous operations and mission success. These are for main thing is to check the health and the safety and the reliability which the satellite is going on in the orbit. The satellite should be strictly monitored by the angles which is it is changing, or it is whether the information is coming correct or not. We should check it properly. So we need the CTM, DTC and M to check this all. So coming to the satellite voice telemetry subsystem. Telemetry refers to the process of gathering data from the remote source, in this case a satellite, and transmitting it back to the ground station. The vital data provides a comprehensive overview of the satellite's status and performance. There are two types of telemetries: housekeeping telemetry, payload telemetry. Housekeeping telemetry is for monitors the satellite health and operational status, including crucial parameters such as voltage and current levels across the various systems, temperature readings of the critical components, altitude in the space, satellite status of the power systems, propulsion, and thermal controls. These are the things which we can see in the housekeeping telemetry. Coming to the payload telemetry, it relates the data to the generated by satellite primary mission instruments such as scientific observations, communication data, or earth imaging. The telemetry subsystem is responsible for data acquisition from various sensors, formatting and encoding to the data into a transmissible signal and downloading it into the ground station. The continuous flow of information should be carried without any crucial for fault detection, performance analysis, and informed decision making throughout the satellite's operational lifespan. And coming to the tracking subsystem. The tracking subsystem is a pinpointing or orbit ice. The tracking subsystem is a fundamental for precisely determining a satellite position and velocity in orbit. The capability is paramount for maintaining mission integrity, ensuring accurate data, and transmission for preventing collisions. Several advanced techniques for the robust satellite tracking is given. It's like ranging, Doppler shift measurement, angle measurement. The ranging allows the time. This time delay combined with the known speed of light allows precise distance calculation. Whereas the Doppler shift, by analyzing the change in frequency of signals transmitted from the satellite, engineers can determine the satellite's radial velocity related to the ground station. Angle measurement uh, utilizes ground station antennas to measure the precise angles like azimuthal angle and elevations angle. These are the look angles which are used in the satellite communication at which the signals are received. This helps to determine its angular position in the sky. And coming to the command and monitoring guiding the satellite's actions. These are the command system provides the ground control team with the ability to remotely control and configure the satellite. The critical functions allow for adjustment to ensure optimal performance and respond the unforeseen. So, in the common types of commands like attitude control, power control, payload configuration, orbit corrections, these are the commands which we can do with the performance of command and monitoring section, and give the commands to the satellite which it should change or it should correct its measurement or the values to get the satellite right. And these are the integrated operational view which we can see along sensors, telemetry encoder, and followed by transmitter and antenna, and followed to the ground station. And these are the diagram outlines of the of working principle of the TTN systems. During normal operation, sensor on the satellite communication data, which is encoded transmitted to the ground station, the satellite antenna. Simultaneously, the ground station sends the information to the satellite. Satellite sends to the receiver. This is the thing which is happened in satellite communication, where the system should also be in orbital position, which it should check it orientation. So these are sensed by the sensors and and transmitted to the monitoring systems, which the TTC system will correct those and keep the satellite in a right orientation and make the satellite work easier. This is the topics I am here to discuss, and I have discussed all the topics. Hope you get some knowledge in this, and thank you.